In this video, I will explain what mathematics is. I will focus on 1. Getting to the point without beating around the bush, and 2. Providing explanations that are easy to understand and feel rather than emphasizing academic precision. I will deliver the message in a concise and straightforward manner. What is mathematics? From today's perspective, mathematics is a science that studies patterns or regularities. The concept of what mathematics is has gradually changed over 2,500 years. Initially, mathematics was thought to be a science of numbers. Then, as shown in this chart, at times it was considered to be primarily geometry, and at other times it was thought to be a science not only of numbers, but also of form, motion, change, and space. Today's scholars, however, consider mathematics to be a science that studies patterns or regularities. In conclusion, mathematics can be summarized as a science that studies patterns or regularities. Let's take a look at an example from a movie to understand what mathematics is. The movie I will use as an example is Gifted. The movie depicts the growth of the protagonist, Mary, a mathematical genius. However, it seems like the filmmakers had no knowledge of mathematics. Therefore, we can identify some common misconceptions about mathematics. In the movie, Mary demonstrates her genius at a young age during a math class in elementary school. The teacher presents her with complex addition and multiplication problems, and Mary easily solves them. The movie portrays her as a mathematical genius, but this is a wrong concept of what a mathematical genius is. That's not what mathematics is. Being good at mental arithmetic or numbers is not the essence of mathematics. Because of this misconception, many students lose interest in mathematics after middle school in Korea. In the 1980s in Korea, TV shows often featured people who could perform mental calculations faster than computers, but not a single one of them became a world-renowned mathematician, and this is not due to the Korean education system. While they had outstanding abilities, their skills were not in mathematics, but in arithmetic. Then, what about real mathematical geniuses? Let's look at the case of Gauss. This is a famous story. It is said that when Gauss was in the 3rd grade of elementary school, his teacher gave the class a calculation problem to do while he took a break from his many duties. Everyone add up the numbers from 1 to 100. Let me know when you're finished, the teacher said. He expected the task to take at least 30 minutes, but one student raised his hand after only a few moments. Teacher, I've finished the calculation, Gauss said. The teacher asked him, "What's the answer?" "It's 50-50, Gauss replied. It was correct answer. The teacher asked, "How did you do it?" Since electronic calculators did not exist at the time, there was no need to check the student's belongings. Gauss explained, "When you add 1 to 100, the answer is 101. If you add 2 and 99, it's also 101. This way, there are 50 pairs that add up to 101. Therefore, if you multiply 101 and 50, you get 50-50. This was the moment when a mathematical genius, unparalleled in human history, emerged. When we hear stories like Gauss's, we can feel that the child is a genius, even if we don't know what math is. Let's think about the essence of math that we can learn here. What did Gauss do? He recognized patterns within numbers. For example, 1 plus 100 equals 101, and 2 plus 99 equals 101. Even if Gauss recognized such patterns in a different problem and solved it, he would still be a mathematical genius, as we can see here. Math is not just about calculation skills for numbers, but about knowledge of the relationships between objects. It is completely different from doing complex calculations in your head that can be done with just a calculator. I believe that this is no different from seeing through the laws of the world, an enlightenment. In that case, the enlightenment means mathematical principles. What do we learn in math class? We actually learn this type of thing. For example, even in polynomial problems, pattern recognition appears, as in any other field of math. Let's take a look at the following equation. It's a very simple equation, but it becomes difficult when something complex is substituted for m or a and b. The pattern changes significantly. For example, let's substitute a plus b for m. Then the formula ma plus b becomes the square of a plus b, which eventually simplifies to the square of a plus 2ab plus the square of b. The important mathematical point here is recognizing that the square of a plus 2ab plus the square of b is the square of a plus b, which is equivalent to ma plus b. It's pattern recognition. If we substitute a minus b for m, it becomes even more difficult. As we know, this equation becomes the square of a minus the square of b. Recognizing that a minus b, a plus b is the pattern for ma plus b is not difficult. However, knowing that the square of a minus the square of b is the pattern for ma plus b is quite difficult. If you know this without learning it, you may not be a Gauss-level genius, but there is a good chance that you will be called a math prodigy at school. If a long and complex expression is put in the place of m in ma plus b, a much more confusing expression appears. It looks quite difficult, right? However, this form is actually easier than the square of a minus the square of b. If you count carefully, you can find it. Likewise, math is pattern recognition. In mathematics, we find simple patterns in complex phenomena, and this can be described as finding regularities. Patterns are equivalent to regularities. If you can discover patterns that others are not aware of, you can almost become all-knowing. For example, if you can identify patterns in stock prices, you can become the richest person in the country in a month. This is why great mathematicians and engineers are working in the financial industry to find patterns in stock prices. Encryption and decryption are also a battle of patterns. Creating an encryption means hiding a regular, meaningful pattern in something irregular, meaningless. Decryption is finding a pattern in something irregular. If you have this ability, you can become the person that intelligence agencies in various countries are looking for. However, not everyone can have this ability just by studying mathematics. So, there is a high possibility that you may fail to find patterns in stock prices, but don't worry. If you have a good understanding of mathematics, you can pursue engineering and study mathematics from the beginning to the end. If you are good at math but do not want to pursue engineering, you can become a quant and work in the financial industry, earning a lot of money just by using your math skills, as far as you are good at math. Hold on. What is a quant? It is an abbreviation of the term quantitative analyzer, which means a quantitative analyst in literal translation. It refers to people in the U.S. financial industry who use mathematics to generate profits through financial algorithms. It is becoming increasingly well-known in Korea as well, so there are books introducing quant, so please read them once. The desire to study math can grow rapidly with a desire for money. Studying math to make money? Isn't that a bad thing? In fact, most people study to find a job that makes a lot of money. Let's review what mathematics is once again. Mathematics is a science that studies patterns or regularities that exist in the world. The appearance of regularities is a pattern. Doing arithmetic or drawing shapes is not mathematics. Numbers and shapes are just one field where mathematical patterns are extensively studied. Studying these patterns, mathematics is so fascinating, don't you think? Thank you for watching. If it was helpful, please hit the like and subscribe buttons once.